back to my session. It is going to be lecture number 23. However, this lecture must be 22 only. Okay, after that, the previous lecture must be 23, but it's fine. I will reorder the sequence in the playlist, right? So today we will be learning how to compute, how to compute probability. Okay, whenever joint distribution is given, like joint density function is given. And also we will learn how to draw this region of support, right? Because last time also I introduced the importance of region of support, right? Region of support must be positive, strictly positive, okay? So that you can find out the region, so that you can find out the area, right? You can find out the probability, right? That's it. So let me start, this session. So this is going to be lecture number 20. Let's say 23 only, no problem. Okay, whatever sequence you have to, at the end of the day you have to learn it. Okay, so as I told you that joint density function, in two dimension, if I talk about joint right, probability density function, joint density in, you can say, two dimension, right? Two dimension in the sense that we are just considering two random variables x and y, right? So a function, function will be like this, function x comma y, x y. Sometimes x and y are jointly written. I mean, comma will not be there. Okay, so this is a function. If it is said to be jointly, you can say joint density function. If it is, you can say JPDF. So it should follow some of the criterion, right? Some of the properties. So first of all, it must be strictly positive, that you have to remember. Okay, I mean, it should be non-negative or strictly positive also, you can say. And second one is very natural. Area under the density function must be equal to 1, right? Dx dy. So here double integral we are using because of two dimensions, right? Okay, if there are three random variables, so we have to use three, you can say that three triple integral as well. ठीक है, सी कुछ प्रॉपर्टीज हैं जो आपको समझना है, right? And the last one is nothing but what you can say, that this function, the joint density function, is piecewise continuous. Okay, you should say in each variable, right? Technically, if you say that, so it is nothing but a piecewise continuous, okay, in each variable. In each variable it is piecewise continuous, right? So suppose we want to find the probability, right? Today's session is totally going to be focused on finding probability of x and y belonging to certain region. Okay, certain, you can say, region. Okay, and if the joint density function is given, so for every joint density function there exists two jointly distributed continuous random variable, right? Remember, for every joint density function there exist two jointly distributed continuous random variable x and y, such that for any two-dimensional region, okay, for any two-dimensional region, okay. So let me write here, for every joint density function, for every joint density function x comma y, okay, there exist two, right? There exist, okay, there exist two jointly distributed continuous random variable, two jointly distributed continuous random variable, okay, x and y, such that for any two-dimensional region, ये important है, for any. So they will ask question, if there are two random variable, right? So they will ask question. Okay, so you have to find the area of that particular two-dimensional region. So for any, you can say that for any two-dimensional region, not okay, dimensional region, you can say A. Suppose they are asking that the probability of, you know, the probability of X and Y falling in this two-dimensional region, right? A is nothing but a two-dimensional region. As long as we know that we cannot, realize three dimensions, right? I mean, it's okay. It's hard to picture three dimension, four dimension and all. So better what we can do here is we will try to picture two dimensional, right? That's it, okay? And if they are asking that what is the probability of these two random variable x and y, falling jointly into this region, okay, this two dimensional region. So what you have to do here is you have to simply integrate. Or you can say that you have to simply integrate, okay, over this region A, right? And your density function is gonna be fx by dx dy. But as you can see, there is a double integral, okay. So I will tell you the strategy, or you can say technique. Not every time you have to compute this double integral, okay. There are some situations where you have to apply this double integral, okay. But as far as the definition is concerned, this is the, okay, uh, probability of two random variable like x and y jointly falling into this two dimensional region A, okay, is going to be this. Understand? So I think this is clear, right? So what is this, guys? This is nothing but, what you're trying to find out. You're trying to find out the, area of this region A only, right? What you're trying to find out is, you're trying to find out the area of this region A only, right? Okay. Okay. So basically, you have to, first of all, you have to start with the support, okay? Support is going to be basically, support of, you can say x comma y. Okay, this support has to be in this format, okay. Your x and y such that, okay, x and y such that your joint density function must be strictly positive, right? What is support? Is someone is going to ask you what is support, right? So your support means this guy must be strictly positive, you can say. Your JPDF, okay, joint density function, right? So whenever joint density function will be given, you have to first try to sketch the support, right? Okay. Support is very important to be sketched so that you can perform integration, you can also find the probability without integration. ठीक है, तो मैं आपको बता देता हूं कि सबसे पहले रीजन ऑफ सपोर्ट ही ड्रॉ करना है. जिसको ये टच माइंड में हिट नहीं कर रहा है, दे कैन एनी टाइम रीच आउट टू मी, राइट? इनफैक्ट व्हेन आई वाज प्रिपेयरिंग फॉर गेट, तो मुझे भी समझ नहीं आता था. क्यों? मुझे तो पहली बात कोई टीचर ऐसा पढ़ाया नहीं था, द वे आई एम टेलिंग यू, राइट? सो पहले ये सारी चीजें नहीं पता रहती थी. ठीक है, डायरेक्टली क्वेश्चन सॉल्व करो. ओके, फाइन. So you see here, guys, support x comma y, x comma y greater than 0, right? So it is strictly positive. Okay, I believe this is fine. So support must be strictly positive. So let me take one very simple question, in fact. Okay, so the example here I'm taking is as you know that I always take the example of uniform in unit square. Uniform in unit square, you can say. Okay, uniform in unit square. What is the question here? The question says that, let me directly take the question, okay, from the okay. So what is this question is, you will find that the joint density function is uniform. Okay, joint density function is gonna be uniform. Okay, and the question, there are two questions basically. See, let x and y have joint density. You see x comma y, okay, which is 1, and here this is given as what? Region of support. You see here for x, it is uniform. You can also write this as uniform, right? 0 and 1 into 0 and 1, right? Like this you can say, or needless to write two times. One time is enough, right? So x and y are two random variables which are uniformly distributed, right? And why I'm saying it is uniformly distributed, since you can see here, this is analytical formula they have given. So 1 is given, right? Density function is equal to 1 in this region. You can say 0 and 1. So what is the question? There are a couple of questions that we have to answer, right? Okay, so this kind of question you might expect. So you have to notice this is the case 1. Okay, this is, you can say, kind of category 1 problem, right? Based on uniform in unit square. Okay, so you can put as a category 1 problem. Category 1 problem, right? Okay. Now the question is, since we have got this joint density function, and they are asking we have to sketch, we have to picture the 3-dimensional plot of the joint density. Okay, so you know that we don't have to picture 3-dimensional plot. We have to basically picture 2-dimensional, only, right? That support has to be drawn for 2 dimensions, but they have asked for 3 dimensions. I think this is clear, right? So you have to have the mental picture in your mind. Acha, there is third dimension as well, right? See, x and y is there, 2 dimension, but there is also one third dimension. You can see, you can imagine like suppose we are trying to build some blueprint of, you can say, some building. Okay, आप ऐसा इमेजिन करो कि आप बिल्डिंग का ब्लूप्रिंट बनाना चाहते हैं, ठीक है? तो आप क्या करते हो? आप सिंपली 2 डायमेंशनल पिक्चर ड्रॉ करते हैं, राइट? 2 डायमेंशनल। लेकिन अगर आप ब्लूप्रिंट, उसका जो ओनर है वो बोलता है नहीं, मुझे तो कंप्लीट पिक्चर चाहिए, ठीक है? तो यू विल ड्रॉ समथिंग, सो आप इतने बड़े बड़े जैसे बार ग्राफ टाइप के है ना, आप छोटे छोटे वो बना देते हैं कि हाँ, दिस इज द बिल्डिंग, राइट? सो यू हैव टू आल्सो गो अप, राइट? दैट इज द थर्ड डायमेंशन, ठीक है? So in that happens in histogram, right? Histogram. Okay, so picture the 3-dimensional plot of joint density. So you have to have the mental picture. Okay, remember that. But I'm not going to draw the 3 dimension. It is slightly complicated, right? So आप समझना इसको, ठीक है? मैं क्या बोलना चाहता हूँ? तो आपको सबसे पहले क्या करना है? You have to draw the region of support, right? ठीक है? So so let me draw it. So let me draw everything in this is the solution here. So let us draw here, okay, region of support. That is the first step that you have to perform. So this is nothing but x, this is y. Okay, there are 2 random variables, and they are taking up the value. You can see here this is 0 to 1 and 0 to 1, right? So this is 1 comma 1, right? And you can also have do like this, okay, so that you will be able to understand this is a this is nothing but a support, right? I believe this is fine. Yes, but this support is coming out of the paper. You can imagine like this, okay? I mean, there is a, you can say that slice coming out, okay? Just to have the mental picture in your mind, I'm telling, right? So this is nothing but a support, you have to remember this is support x comma y, okay? This is support x comma y. Understand? So this picture, first question was picture the 3-dimensional plot of the joint density, right? Understand? We have to picture the 3-dimensional plot of joint density, right? And if I want to validate whether this joint density function is, you can say that area under the joint density function is 1 or not. So what we have to do? We have to integrate it, right? So you can say that area under, right? I mean, not area you can say, but simply you say that 0 to 1, 0 to 1, it is 1 only, dx dy, okay, that must be equal to 1. So how to do this? I think this integration is very simple. Okay, so x 0 to 1 and then by 0 to 1, right? So it is 1 only. Okay, it is gonna be 1 only, right? It's a very simple integration, right? So you can do, first you can perform with respect to x, then you can perform with respect to y. Okay, treating one. Okay, so what kind of question you might expect is they might ask you so what they have asked in this question was picture the three-dimensional plot of the joint density. So you have to draw the support. And how to draw the support? With the help of this. Okay, you have to draw the support. Then they will help you to draw the support, right? And then you have to compute the probability. Okay, to compute the probability, you have to find the area of the region. Okay, so which region? The region you have to draw. The region is this. This is the region. If you want to find the area of this, you have to integrate it, right? Okay, so this is the answer 1. Okay, okay, support has got the area, complete area, if you are trying to find the area, and you don't have to perform this integral also, since it is a rectangle. Okay, unit square. So what is the area of unit square? The area of unit square is nothing but area of a unit square is nothing but 1 only, right? So you don't have to compute this, okay, separately. Okay, I hope this makes sense. Okay, so they are not asking you to find out the probability of x and y falling into some particular region. Okay, they are asking you to compute the probability of entire support, entire region, है ना? लेकिन मान लो तुमसे पूछता है, suppose they are asking, suppose you have got this kind of a support, right? This is support and it is a unit square only, 0 to 1, this is x and this is y, right? And suppose they are asking you what is the probability of x comma y falling into a region A, right? A region A. Okay, so what is that region they are talking about, right? So let me help you out here. So they are asking you to find out the probability of this region, you can say. This region, this is the region A, right? Okay, this is the region A. Now, as long as this problem is concerned, this is a unit square. Your region of support is unit square, right? But they are asking you to find out the probability of this region. And this region can be, it can be square as well, it can be triangle, it can be any random shape. Okay, agar koi random shape hoga, then you have to use the integration. Okay, but if if it is a square, rectangle, circle, right, है ना, तो आप डायरेक्टली एरिया बता सकते हैं. तो व्हाट यू हैव टू फाइंड? यू हैव टू फाइंड आउट द एरिया ऑफ द रीजन ए. दैट्स इट. सो आपको ऐसा लग रहा होगा कि सर यू आर स्केचिंग 2 डायमेंशनल पिक्चर, राइट? यू आर नॉट ड्रॉइंग 3 डायमेंशन, but in the question they have asked to picture 3 dimension, right? So while computing the joint density, you have to always picture this kind of a figure only, right? Okay, you don't have to show the third one, but you must have the mental picture in your mind. Understand? I think this is clear. Yeah, so आपको इस रीजन का एरिया फाइंड करना है, रीजन ए का एरिया, राइट? ओके, so I mean to say that this will be equal to, okay, if they are asking you to find out the probability of x comma y, right, falling into belonging to this region A, meaning that you have to find the area of region A. What is the meaning of that? Region A means you have to put the limit, you have to set the limit of integration, and then fx by x comma by dx dy, and we know that this fx by this is given as dx dy, right? So it is simple area only, dx dy. You see, It is simply a area of the region, right? Very simple approach. Okay, I think this is clear, right? Fine. So this is what they are asking you to compute, right? This concept is valid. Remember, this direct computation of area of that particular region is valid for unit square case, guys. If the region of support is unit square, right? Okay, then only please directly compute the area of that particular region. Okay, I think this is clear, right? Okay, and your density function is uniform here. याद रखना, this is only valid for this case. Okay, understand? So let me take one case here, right? The case, like, this a, if this a, the reason is, if region a is, you can say that square, right? Kind of square, you can say that. Okay, square. Okay, offside, you can say that 1 by 2, right? So we can say that, suppose this is a region of support, right? This is x, this is y, and this is the region of support 0 to 1. Okay, this is the region of support. Okay, but what they are asking is, they are saying that x and y falling, right? You have to find the probability of what? X and y falling into this region, right? I mean, they are asking this question. Okay, so this is the region, okay, A. So what they are trying to ask you is, suppose this is 1 by 2 and this is 1 by 2. So they are asking this region. Okay. So what you have to find out? You have to find out the area of this, right? You don't have to perform integration here. Okay. Because your density function is also given as, that is given as 1, right? So needless to find. So what is the area? 1 by 2 into 1 by 2, which is nothing but 1 by 4. Answer. So this is nothing but, remember, this is very important. Okay, this is the A, like x and y belongs to this A. They are falling into this region, and simply you have to find the area of this guy. Area of the region A, right? I think this is clear, right? So in the exam, they will mention this kind of question. Okay, they will give you the density function, a joint density function, and then they will ask you to compute the probability of, x and y falling into this region. Okay, they will give you some range of, x and y, so that you can find out the probability. Okay, so this formula, this definition, area of the region A, is valid only when there is a uniform, your density function is uniform in the unit square, right? Your density function here, it is given as 1, okay, or a constant, right? In the uniform, okay, right? So let me take few more questions, right? The same question, but I'm just going to ask some of the more questions, right? So next question. See, the question is gonna be same only, right? Same question, you can say same, but we have to now find some of the probabilities, right? So let me, you can say that, suppose this is a question, same question, right? This is the same question, right? Uniform in unit square case, right? How can I identify this is the uniform? Okay, then you can also say that x and y are independent, right? If they are asking about independence. So suppose the question is, what is the probability of, suppose they are asking this question. The very first question I am asking is this. Okay, so x and y have the joint density, right? You can say x comma y here, right? So first of all, you have to plot it. So the very first step is you have to plot. So plot कर सकते हैं. देखिए. Don't worry about 3 dimensions. You have to plot the 2 dimension, as I said you, but you should be having द मेंटल पिक्चर इन योर माइंड, ठीक है। आपको एक मेंटली इमेजिन करना है कि हाँ ये ऐसे जा रहा है, जस्ट लाइक अ बिल्डिंग इट इज, यू नो, आप ऐसा सोच सकते हो हिस्टोग्राम टाइप का। So here you can sketch one by one square, unit square, right? So this is your region of support, or you can say kind of support only, x comma y. Now what they are asking is they are asking you to compute the probability, right? So find the area of the region. Okay, so to compute the probability, what we have to do? We have to find the region, area of the region in this case. So what is that region they have given? This is the region, you know, x is taking the value, you can say. Okay, so this is A, right? X and Y belonging to A. So, you know, X takes the value, you can say 0.1, and Y also takes 0.1. So this is the region. So what is the answer for this question, guys? At the end of the day, this picture is also square only. So answer is going to be 0.1 into 0.1, which is 0.01 answer. Okay. So I think this is clear for all, yeah? I hope this makes sense. The same question, but they are asking you to compute the, you know, probability. Okay. Same question, but they have given some different, you know, okay, reason A. So X and Y belongs to, you know, falls down to this region. So let me again sketch the same, you know, region of support first. Okay. आपको बार बार ड्रॉ करना है, तो that will give you the practice. You have got the unit square. It is one of the simplest support that you can imagine, right? Okay, it happens only, remember this directly finding the area of this region which is inside this probability. You see probability of that range is only valid whenever your density function is uniform in the square unit square. ठीक है, अब देखो ये कहां से कहां ले रहा है, तो योर x is from 0.5 to, you know, 0.5 to 0.6, right? So 0.5 कहां पर है, मान लो ये है 0.5 to 0.6, okay, and your y is nothing but this, right? So y is going to be 0.1. So this is the situation here, right? So what is the area of this, guys? I mean, area of this square or whatever rectangle you can say. So see, the width is 0.1 and the height is also again same answer, right? There is no change in answer. Okay, any shape it can be, right? But the answer is same, right? You see, okay, you have to simply find this area, right? Okay, I think this is clear. So the very simple. Okay, you see how simply I'm finding the answers, right? Okay, so let me go to next question. So they are asking you to compute the probability of this. Okay, so probability, you know, x lying between 0.9 to 1, 0.9 to 1. Okay, so let me take the again x by, okay, and this is the unit square where your density function is uniform, right? And then this is the region of operation, okay, the region of support, sorry. Okay, and now what they are asking is to compute the probability of x and y falling in this region. This is the region, okay, they have mentioned. So x is from 0.9 to 1, so you can say this is 0.9, and y is from 0.9, so this is 0.9 to 1, right? So they are asking you to compute the probability of this region. So, you know, at the end of the day, this is what, 0.1, and this is again 0.1. So answer is gonna be 0.9 to, sorry, 0.1 to 0.1, which is 0.01. See, this region A can be anywhere. This region A can be anywhere, right? As long as this is uniform in unit square, so this region is also you can say that you can imagine this is a square, okay, only, and you have to just find the area of that particular region for which they are asking you to compute the probability. That's it. In case of this case, remember this is very important case, okay. I will tell you all the varied cases, right? All the cases, so that any question asked in the gate examination you will be able to solve. But आपको समझते चलना है, ठीक है? I think this is clear. Okay. I believe this is fine. Okay. So let me take more questions. Okay. So let me take this question. Okay. So fourth question is this. Now they are asking you to compute the probability of over one dimension, right? Only x. Y is constant here. Okay. So they are asking you to compute the probability of this. Okay. Where x, y is constant, right? So again, you should be able to draw the region of support. Okay. That is 0 to 1 and 0 to 1. So since they have said that this is the region of support, right? But they are asking you to compute the probability of this, okay, like x lying between 0 to 1. So by can take any value, right? So by can go like this. So this is the answer, right? So iska answer आ जाएगा 1 into 0.1, which is 0.1 only. Right? And suppose they are asking you to compute the probability of, suppose they are asking you to compute the probability of, by taking, you can say that by taking the value 0.5 to 0.6. Okay, so इसका आंसर कितना आ जाएगा? तो फिर से वही बात, you can sketch all these two-dimensional plots, right? X comma y, right? Unit square, and now this is the region of support, right? You can sketch like this, and then okay, and then you can mark here. This is 0.5, 0.6. So this area, right? So 0.5, 0.6. What is the area of this? 0.1 into 1. That is 0.1 only. Because okay, x can take any value, right? If x is not mentioned, x can take any value. Okay. Okay. I think this is clear, right? So let me take one very important case. Like now this is important, and this kind of question has been asked also many times in the gate examination, right? So let's say they are asking question of this kind. Suppose you have been given you have been given the joint density function of this kind, right? And they are asking you to compute the probability, right? What they are asking? They are asking you to compute the probability of the probability x larger than y. They are asking you to compute the probability x larger than y. It is slightly different, but fairly easy thing, right, to do. देखो आपका केस अभी सेम है, रीजन ऑफ सपोर्ट इज x comma y, but now they have given you the reason differently, right? They haven't specified x range and the y range. Okay, they have given that the random variable x is greater than y. Okay, so please treat this question as you kind of it falls under category 1 only, लेकिन आपको थोड़ा सा इसको स्पेसिफिकली स्टार लगा लेना है कि हाँ ये थोड़ा सा अलग है, इसमें थोड़ा सा अलग करने वाले हैं, ठीक है? What is the step number 1, guys? Step number 1 is gonna be first sketch the region of support. तो अगर आप sketch करते हैं, sketch the support. Okay, so I can sketch here. You see, the very first step is this. So sketch is gonna be unit is 0 to 1. X and y, right? X and y. And the second one is then what you have to do, you have to come to this probability, right? So you have to draw this region, guys. You have to think about this region, where this region is inside this unit square. ये x greater than by कहाँ पर है? This is a region at the end of the day, right? And you have to find the area of this region, okay, in this case. Here also you have to find the area of this region, x greater than by, okay, but first of all you have to realize, so this is a strict inequality. So you can imagine, you can say that x, you know, x greater than by का मतलब क्या होता है? X equal to by you can take. Okay, x equal to by. So x equal to by is going to be like this. This is x equal to by line. Y equal to x line, right? And where is x greater than by? X greater than by is gonna be this. This is x greater than by. Okay. So what is the reason of this guy? We are asking probability of x greater than by, which is nothing but the reason of area of, you can say this is a reason, right? A reason. This is a. So what is the area? At the end of the day, this is triangle, right? अगर ये triangle है, इसका area क्या हो जाएगा? 1/2 into 1 into 1, which is 0.5. यही आंसर है इसका. Okay, this is the answer only. In the same question, if they ask you what is the probability of, same question, similarly, what is the probability of y greater than x? So y greater than x. So let me again try to compute. I mean, you can directly answer, but it's fine if you do not understand. So you can draw the, I will tell you direct answer also. In case of 0.1, I mean, unit square. Now you have to draw this line. Okay? Understand? So this should pass through, strictly pass through this point, okay, because that is y equal to x line. ये क्या है? y equal to x line है, ठीक है? Now they are asking you to compute y greater than x. What is y greater than x? You know, y will be greater here. This reason. So you have to find the area of this, right? So again, 1/2 into 1 into 1, which is 1/2. And one more thing you can notice here, what important thing that you can notice here is, see, the area under the density function must be equal to 1. That everybody knows, right? The area under the density function must be equal to 1. And in this case, area under the density function means what? Like, you know, it is a region of support and your density function is constant, so you can directly find the area, right? So area means probability, okay, and you can say that the probability of x greater than y plus the probability of y greater than x, okay, plus the probability of x equal to y, which should be equal to 1. Okay, this is important to remember. And as long as the x and y are continuous, right, you know, so the probability at x equal to y is gonna be 0, right? Okay, so you can see here, so the question comes is x greater than y plus probability y greater than x is equal to 1. Understand? And one more thing you have to notice here is that these x and y, okay, if x and y are independent, and certainly they are independent, right? Okay, independent, then we can use the concept of symmetry. Remember this, independence implies symmetry, right? So in the exam, so directly you can say that the probability of this is half, the probability of this is half, if you want 1 as total, right? Okay, so remember, independence implies symmetry here. Independence implies symmetry. So in the exam, they will give you this kind of a question, right? Let me give you also. They will say that x1 comma x2, okay, are IID. What is the meaning of IID? IID means independent identically distributed random variable. Independent, they will mention it is independent identically distributed random variable. You can get this kind of a question as well in your exam. And I think if you notice your PYQ also, you will find some questions, right? So they will say that I'm giving you the sample question, right? You might find this kind of question. So they will say that there are two random variable x and y, or they will say there are two random variable x1 and x2. Okay, there can be three random variable, four random, 5, 10, जितने भी दे सकता है, right? So they will say I'm starting with very basic, right? So we are going to exploit the symmetry here, right? Since they claim that these two random variables are independent, right? So if x1 and x2 are independent random variable, right? So and they are saying that x1 and x2 are independent identically distributed random variable over you can say that uniformly distributed. Identically means uniform in this region 0 to 1. Then what is the probability that what is the probability of x1 greater than x2? ये क्वेश्चन दूसरे लैंग्वेज में वो पूछ सकता है. This is a sample question, or they might ask what is the probability of x1 being largest. Okay, so x1 being largest means what? X1 is greater than x2 only, or x2 being smallest also they might ask, right? X2 being smallest. Okay, same question, answer is gonna be same only. What is the probability of x2 being smallest? Since there are two random variable only, certainly one will be largest, one will be smallest, right? So these are the question, they might ask you, right? So how to tackle these kind of a question? Whenever IID word will be there, IID, right? Independent, identically distributed random variable. So you have to always use the concept of symmetry. Okay, try to understand symmetry concept, guys. ठीक है, अगर आप सिमेट्री कॉन्सेप्ट समझ जाते हो ना, योर लाइफ इज वेरी वेरी सिंपल. ठीक है, प्लीज ट्राई टू अंडरस्टैंड दिस सिमेट्री कॉन्सेप्ट. ओके, so IID means you can just plot this. Okay, so first is x1 and this is x2, right? And you just draw the region of support that is uniform in unit square only, right? This is the region of support they have given. But now they are asking you to compute the probability of, they are asking you to compute the probability of x1 greater than x2, right? So first of all, you have to draw the x1 is equal to x2, and we know that in case of continuous random variable, probability of x1 is equal to x2 is 0, right? So probability of equality will always be 0, remember. Okay, वो मैंने बता दिया है पहले ही. ठीक है, so you don't have to worry about that because it does not have any sort of reason. So this is x1 greater than x2, right? ठीक है, so if they are asking probability of x1 greater than x2 means what? You can say that probability of x1 greater than x2 is equal to probability of x2 greater than x1. दोनों सेम होने वाला है, right? दोनों सेम, both will be same only by symmetry, you can say by symmetry. Okay, so this region, area of this region both will be same. So total must be what? Total must be, and you have to always make sure that you have to keep in mind that x1 equal to x2 is always 0, guys, in case of continuous random variable. Okay, so if you try to use the total probability concept, right? So you can say that probability of x1 greater than x2 plus the probability of x2 greater than x1 plus, let me introduce all the cases. x1 is equal to x2, which is 1. Total must be 1, right? ठीक है, so this is going to be 0, right? So, if you want 1 here, right? So this must be 1 by 2 plus 1 by 2. Then only you will get 1. So answer for this question is what? 1 by 2 only, right? Answer for this question is 1 by 2, right? So this is coming out from the, you know, uh, symmetry, right? And you can also notice on this region of support, like x1 greater than x2 and x2 greater than x1. Okay, if you take x1 greater than like x1 is equal to x2, where this is x1 equal to x2 line, right? Okay, that is nothing but a line of symmetry you can consider, and answer is gonna be 1, right? Okay, so suppose if they have given question of this kind, like suppose they said that x1 greater than x2 greater than x3. Okay, they are IID, right? Again, independent identically distributed random variable on 0 and 1, right? So they might ask question, what is the probability of x1 being largest? ये question आ गया मान लो. This kind of question you might find, right? In your PYQ also, this kind of question is expected. So what is the probability of x1 being largest? Now, since they have claimed that this is IID, like independent, identically distributed random variables. So please use the concept of symmetry, right? Use the concept of symmetry, right? Remember. So now, plotting support is not that easy, okay? Because there are 3 random variables, right? 4 random variables. So needless to plot the support. You can use the total probability concept and use the symmetry concepts, right? Okay. So let us write down all the cases. Okay, like x1 being largest means x1 must be greater than x2, x3. See, sometimes x1 can be also equal to x2, right? So remember that, like suppose probability of x1 is equal to x2 greater than x3. This will be always 0. So remember, wherever equality sign will exist, we don't have to consider that case. Okay, what are the case that is possible here? All the cases, let us list down केसेस. ठीक है, तो आपके पास क्या क्या हो सकता है? x1 ग्रेटर देन x2 ग्रेटर देन x3. ओके, x1, okay, let me write again. x1 greater than x2 greater than x3, right? There are 3 random variables, so x1 has to be, okay, like this in the first only, right? Now x1 will be here, so you can say x1 is greater than x3, and this is also possible. But and this is also possible, guys, like x1 can be equal to x2. Please don't consider that, okay? Because probability of any event, like if x1 is equal to x2 kind of thing, that will be always 0 in case of continuous. ये मैंने पहले बता दिया है, ठीक है? So x1, these are the 2 cases. Now other cases are also possible, right? I mean, this x2 can like x1 can be lesser also, right? So now let me take x2 greater than x1. Now x2 here, it will be nothing but here, right? Now let me take x3, and x3 is larger. Okay, so these are the 6 cases which are possible, guys. Okay, that's it. These are the 6 combinations which is possible here. Okay, only 6 combinations are possible. Okay, so what is the probability of, now they are asking what is the probability of x1 being largest, which is nothing but total is 6 here, and the required is this, only 2. So answer is gonna be 1 by 3. Answer is gonna be 1 by 3. Please remember that. Okay, answer is going to be 1 by 3. Okay, so answer for this question is 0.33. You see how simply I have done this question, right? And let's say there are 4 random variables, so answer will be 1 by 4. They might ask question like this also in this. they might ask a question of this kind ki, what is the probability of x1 being sandwiched, right? X1 being sandwiched, okay? What is the probability of x1 being sandwiched? What is the probability of x1 being sandwiched, right? Sandwich matlab, or you can say x1 being in the middle. ठीक है, तो इसके केस में क्या होगा, आप सारे केसेस तो ऑलरेडी लिस्ट डाउन है ना. So how many times x1 is coming in the middle, right? So you see here, this is x1 and this is x1 two times, and there are 6 cases. So 2 by 6, which is 1 by 3. Same answer. Answer is not going to be different, okay? So there can be 3, there can be 4, there can be 5, right? Okay, so please do remember these points, huh? Okay. So अगर मान लो 4 हैं, let me say suppose x1, x2, x3, x4, they are IID and 0 1 में distributed हैं. So they are asking probability of x1 being smallest, right? Whether they ask x1 being largest or smallest, right? Answer is going to be, okay, so answer for this question is going to be 1 by 4, guys. Answer is going to be 1 by 4. Okay, that is 0.25. Okay. I think this is clear, right? So how I'm finding this is, simply you have to take all the cases here, right? x1 greater than x2 greater than x3 greater than x4, then x1, right? So how many cases you can have? You have to permute this, okay? You have to permute this. So यहाँ पर आ जाएगा, now x3 is here, x2 is here, x4, right? Okay. Then x3 is here, x4 is there, x2 is there, right? Now you can take x4 and keep permuting, right? So how many cases you might get, you have to understand. Okay? But you know, equality you have to ignore, right? So answer for this question is 1 by. If there are 4 random variable, 1 by 4. If there are 5 random variable, 1 by 5. Okay. In that case, in that manner, you can always. Okay. So I think this is clear, right? And simply we are counting here, right? Counting is the technique that you can use, right? Fine. So this is the idea, okay? So let's say, let us take some more questions, okay? So probability of x greater than y, or that kind of question they might ask you. मान लो तुमसे पूछा जाता है कि suppose this is a question, right? Same question, okay, uniform in unit square, and they're asking you to compute the probability of x greater than 2 by. Okay. See, they are not asking you to compute the probability of x greater than y. Remember, now you can't use here the symmetry and all, right? That will be wrong. Okay. Because x greater than 2 by is there. They have written x greater than 2 by. So first of all, what you have to do, you have to draw the region of support. ठीक है, ये रीजन ऑफ सपोर्ट आपका हो जाता है. दिस इज द रीजन ऑफ सपोर्ट. नाउ लेट मी यूज सम डिफरेंट कलर. x ग्रेटर देन 2 बाई का मतलब क्या है, आपको x इक्वल टू 2 बाई ड्रॉ करना है, विच इज नथिंग बट y इक्वल टू 1 बाई 2x. द स्लोप मस्ट बी हाफ, राइट? द स्लोप मस्ट बी हाफ, 0 to 1, right? The change in y must be how much? Change in y must be half, right? So this should not go up to, this is 1 by 2 only, right? So you can say that this is the point where it is touching, right? So what they are asking this region, area of this region, x greater than 2 by means this region. This line is nothing but x equal to 2 by line. So x greater than 2 by का मतलब क्या होता है? x greater than 2 by का मतलब this region. तो इसका एरिया कितना हो जाएगा सर? ये भी तो ट्रायंगल ही है ना. So 1 by 2 into height is 1 by 2 into 1, which is 1 by 4. 0.5. Okay. So please remember this. This is not, you can't apply symmetry at this moment, right? Because x greater than 2 by it is given. X greater than by, it's fine. You can use the symmetry. So answer is 0.25. I think this is clear. So how to plot also is very important. How to graph something. Huh? तो लाइन कैसे ड्रॉ करते हैं आपको ये तो पता होना चाहिए ना. You must know that. Yeah. How to graph something. Yes. ठीक है. Now let me take one more question, a very simple question. So please note down these questions properly in your notes. Okay, you will appreciate me. Okay, suppose the same question I am going to take. Okay, like let x and y are, this is uniform in the unit square. Okay. So what question they are asking is, they are asking you to compute the probability of, okay, they are asking you to compute the probability of x square plus y square less than 0.25. What is the question of this? Like, this is the question they are asking. Okay. So if you want to find out the probability of this and joint density function is given, so first of all, what you have to do? You have to sketch the region of support first. Now you may be thinking, sir, how you are drawing this? With the help of this, guys. Okay, x and y, and we have got the unit square. This is you can say 0 to 1. Now this is the support. Okay, and in this support the density function has to be strictly positive, right? Now what they are asking is, let me sketch this region as well. ये एक region है आपका. Okay, this is A. Okay, in this case also this was the region A, right? A है. So x and y falling into this region, we are trying to find the probability. So what is this? This looks like, you can say x square plus y square equal to 0.25. Okay, that is nothing but if you compare with the circle, okay, equation. So this is nothing but x square plus y square. Center is origin. Radius is gonna be r. R is going to be 0.5 here. So 0.5 we can take here, right? Okay. Understand? So radius is gonna be 0.5. So this is going to be your circle, right? This is the circle. We have to draw the circle here, right? This is the circle, but it is not a complete circle. It is a 1/4 of the circle, right? It is in first quadrant only. So this circle, area of this circle we have to find. So I think everybody knows this, right? So area of this region, you can say A. This region is A. It's going to be 1 by 4 into pi r square. And this is 0.5. 0.5. So radius is nothing but 1 by 4 pi into r square is 0.25, right? So it's a very simple, pi by 16 is going to be the correct answer for this question. Yeah. Okay, pi by 16. So it's a very simple concept, right? Everybody can understand that. ठीक है, तो इसका आंसर कितना आ जाएगा? पाई बाई 16. देखो कितना टफ क्वेश्चन, लाइक मेनी स्टूडेंट थिंक दैट कि दिस इज वेरी डिफिकल्ट क्वेश्चन, राइट, बट इट इज नॉट अ डिफिकल्ट क्वेश्चन गाइस, लेट मी टेल यू अगेन, ठीक है। आपको लग रहा होगा धीरज सर कितना सिंपल तरीके से कर रहे हैं, यस दैट इज द फैक्ट ऑफ लाइफ, ओके। सी दीज आर द क्वेश्चन विच आर नॉट डिफिकल्ट एट ऑल इफ यू आर स्टडिंग अंडर द गाइडेंस ऑफ धीरज सर। और गेट एग्जामिनेशन के लिए ये सारी चीजें मुझे भी नहीं पता थी पहले, आई वॉज नॉट फैमिलियर एट ऑल, राइट। आई यूज टू सी, first of all let me tell you one thing, I was introduced this random variable concept in communication system, okay. One of the subject is there in electronics and communication, okay. And there was a need of random variable and random process just to deal with noise, okay, present in the communication engineering, right, communication system. So we were introduced everything as far as and in gate examination everybody teaches some tricks and formulas so that we can solve the pyqs, but they don't teach us any method, general method where we can use, we can use that method to solve any problem, right, that exists in the world, okay. अब आपको ट्रिक पता है, कोई अगर नया क्वेश्चन आ गया तो बैंड बज गई, ठीक है, तो आपको सारे केसेस कवर करने हैं, ऑल केसेस यू हैव टू कवर, ठीक है, अंडरस्टैंड। सो गाइस एट दिस मोमेंट आई वाज टॉकिंग अबाउट यूनिफॉर्म एंड यूनिट स्क्वायर, राइट। सो द एरिया ऑफ द यूनिट स्क्वायर वाज 1 डायरेक्टली, ओके, area of the unit square was 1, but let's say the region of support is there, okay, that describes some particular reason, right, it is other than the unit square, you can say, okay, that we can consider that reason as capital D, okay. So now I'm going to talk about category 2 problem, where the region of support, the area under that region of support is not going to be, you can say, 1, that will not be the unit square, please remember, okay, that is not the unit square, that will be different, it can be 2, area can be 2, 4, 5, whatever other than 1, right. So we have to fix some you can say reason, okay, some reasonable reason, you can say, right, in application you will find, right. So you can say that we are now going to talk about two-dimensional uniform distribution. Two-dimensional uniform distribution, right, okay. Inside that also the distribution is going to be uniform, right. Okay, so what we are going to do is we are going to fix some reasonable reason D, fix some, you can say, reasonable reason D in two-dimensional, that is R2, okay, with total area, you can say, with total area, okay, this is the total area, area has to be positive, so I have written, I have taken the mod of D, okay. So you can say that then we say that the random variable, you can say x and y, is uniform in D, in this region, you can see, in particular region some D is there, okay, if they have the joint density function, if they have joint density function of this kind, right. So remember this is the joint density function, x comma y is equal to, they are uniform in this D, it means the joint density function is going to be 1 by this D, okay, and your x and y will fall into this region D, 0 else. See, outside the region of support density function will always be 0, ठीक है। सो ये एक कैटेगरी है, इस कैटेगरी को आपको याद रखना है, इट्स नॉट अ टफ कैटेगरी, ओके, रिमेंबर, Earlier it was unit. I did not show you. Sorry for that. Please, category 2 problem, right? Two-dimensional uniform distribution. Please write again. Okay, I think you might have missed this. Okay. So please note down this two-dimensional uniform distribution. Okay, so what we have to do here is we are fixing some reasonable region D. Okay, in R2 with total area, you can say D. Okay, this is the total area. Earlier this area was 1. So the problem is same as category 1, that uniform in unit square, right? But now this D is giving you non-unity area, right? It will not give you unit area. Then we can say that X and Y, okay, they are uniform in D if they have the joint density function of this kind. This is joint density function, okay? It is not a probability, remember. Okay. And you have to find the probability of X and Y jointly falling into what? Jointly falling into, okay? So, yes. So as you can see here, okay, so that is very important, right? So two-dimensional uniform distribution only, but this D is other than the unit square now. So your density function looks like this, okay? And you have to find the probability of X and Y falling into this any particular region A, right? They might ask question of this kind, right? Okay. So how to find the probability? That is the question. What kind of question they might ask you? I will tell you. Okay. Okay. So they might ask you, let us talk about some example of these D, right? So your example of these reasonable, you can say reason, you can say D in R2 can be, okay, some of the example I'm giving you, okay, so that you can get familiar before I start finding the probability. So it can be the rectangle, okay, it can be the rectangle, that is very simple, a rectangle, okay, rectangle can be of this kind D, okay, D equal to A B, right, into CD. Now you see here they are different, right? A and B are different, C and D, okay, they are not unity, understand? Or they might say that fine. So as we can see here, these are the reasonable reason, okay, sorry, reasonable reason they might give you, okay, in the question. So आपको कैसे ये पता चलेगा कि this is the region of support, right? So you have to see the range of X and Y, right? And basically we are talking about two-dimensional uniform distribution. So this is one kind of rectangle region you can get, okay, in your exam, okay. They might also give you the same, okay, like they might say that X comma Y such that, okay, such that X takes the value between A and B, right, and comma, you can say that the Y takes the value between C and D. See, whether they might give you in this format or they might give you in this format. So you don't have to get confused, right? You have to simply sketch the rectangle, right? You have to simply sketch the rectangle of this kind. I'm just drawing it, okay? X and Y, and X takes the value, you can say A and B, and you can say that Y takes the value C and D. So your region of support is going to be this, right? Now this region of support is same only, whatever we discussed, but now this is the region of support, okay, it is slightly up, okay. So I think this is clear. So this is the D we are talking about. and inside this D, the distribution is uniform. Okay? You take any value of x, you will find the bi is uniform, right? In fact, conditional density function is also uniform, right? So this is the picture that is you have to draw first, okay? Before you compute the probability, right? So first of all, you have to draw this picture, and later I will tell you how to, and how to find the probability of any, like you can say x and y falling into this region, and particular region, okay? They might give you the circle as well. So this is first, reason that they might give you. Second, they might give you circle. Circle can be also this region D. Okay? So circle का क्या होता है? X and y, right? X and y such that x minus x naught square plus y minus y naught square, okay, is equal to r square, right? So this is nothing but equation of a circle. Sorry, that must be less than or equal to r square, right? So inequality should be given always, right? So this is the circle, okay? Understand? This is a circle that you have to remember. So what kind of circle is this? Here the center is not 0 here. The center is 0. You can say this kind of a center. Let me draw it. Well, this is x and this is y. So you can say that this is x naught, this is y naught something. You go to this point. Now you have to draw the circle of radius r. Right. So this is the D they are talking about. Okay. Now they might give you, they might give you multiple disjoint areas and so many other possibilities. The multiple disjoint areas, okay? And many other possibilities. Okay. So they will be asking you to compute the probability of sub-region, okay? They will not ask you the probability of this entire D, because if they will ask what is the probability of entire D, certainly it is going to be 1 only, right? Everybody knows that, yeah? One, it must be 1, okay? The area under the density function must be equal to 1. So they will ask you to find the probability of sub-region, okay? Sub-region can be A, right? So suppose they are asking you to compute the probability of x and y falling into this region A. So you have to treat this region A as kind of sub-region. इसको आप बोलोगे सर it is a sub-region, right? So let's say you have got the kind of region D, right? This is the region D. Okay, this is the region D. You can say x and y, and this is the region D. Okay, you have got this region D is there, but they are asking you to compute the probability of sub region A. So A region आप बोल सकते हो कि sir A region is this. This is the A region. I'm talking about this region. This is sub region A. So what is the probability of A? The probability of A is going to be area of sub region A upon the area of region D. It's a very simple approach, right? मान लो area of the region D is unit square, then only you have to find the area of sub region A, right? So this formula is important, right? This result is very important, right? It can be the circle also. The area of the circle upon the area of the region. You have to divide. Okay. I hope this makes sense to all. Yes. And how this is coming into picture is, let me prove also. So proof मैं आपको यहाँ बता देता हूँ. मान लो तुम्हें क्या है, if you are using the that definition, the probability of x by falling into this A is nothing but double integral over joint density function x comma by dx dy, and this is given as uniform in D, right? So this is nothing but you can say uniform in D, 1 by D dx dy. Now one you can take this common because it is constant, right? So this is area of dx dy, and this is the area of the subregion. Okay, so the answer for this question is area of A upon area of D. Okay. So instead of using double integral, right, you can directly find the area of a sub-region, area of the region, right? And then you can find out the probability. Okay, life is very simple. Yeah. So this uniform distribution is very good approximation, you can say, okay, for flat histograms. Okay. Uniform distribution is a good approximation okay for flat histogram. Okay, for flat histograms, right? For flat histograms. Okay, so please remember these things. We are just approximating things like, okay, take it. So they will ask you two-dimensional uniform distribution, right? They will say that x and y are uniformly distributed in D, right? And D will be specified, okay, properly. And you have to sketch the support and then you have to compute the probability. Okay. So what we can do here is we will take questions, right? Let me take one question and try to explain you quickly. Okay, and other category I will take like where you have to exactly use the integration. Okay, that is very important case. Okay, that we will consider in the next class, because see, that will be the case of non-uniform distribution. Okay, till now we are only considering the uniform, and in your exam also uniform was asked. Okay, so let's say the question of this kind of question they might ask you. Okay. And you will find in GATE 2024 direct question from my classroom was there, right? Direct question you can say. So let's say x and y is uniform, uniform in D, where this D is also given. So D is given as x and y such that this is a set, okay, like x and y such that x plus y is less than 2. You can take x and y and it should be less than 2, and x must be greater than 0 and y must be greater than 0, right? So this is the reason they have given. And so what are the question, right? The first question is sketch the support. That is the very first question. And second one is compute the probability, right? Okay. Compute probability of x plus y, right? Probability of x plus y less than 1. Okay, this is the first question. And second question they are asking is find out the probability of x plus 2y, right? X plus 2y greater than 1. So these are the two questions they are asking, right? Okay. In the GATE examination this year question was there. Okay. So what is the first step, guys? The first question itself, right? You have to draw the support for this. This is x plus 2, right? X plus 2 greater than, I mean, it must be less than 2, right? Okay. So what will be the region of support, guys? What is going to be the region of support? X plus 2 सॉरी x प्लस बाई लेस देन 2 का मतलब क्या होता है? So you are not able to understand that what is the value of x and y. It is not given in the question, right? X is greater than 0 and y is greater than 0, but they have mentioned that x plus y less than 2. This is the starting idea, right? So x plus y less than 2 means you can draw the picture x plus y equal to 2, right? That picture is going to be like this. Yes, this point is nothing but 0 comma 2 and this point is nothing but you can say 2 comma 0. So this is the d they have given. Yeah, this is the d, and your x and your distribution is uniform in this d, like your x and y random variable is uniform in this d, right? So this line is nothing but the line of x plus y equal to 2. But what they are asking is, so so you should know this area of this d. You can find out the area of this d, right? What is the area of d? Area of d is going to be, this is triangle, right? So area of d is going to be 1 by 2 into height is 2 and the width is also 2, so which is 2 only. This is the area of d we have got, right? But what they are asking is, they are asking you to compute the probability of x plus y less than 1. So if they are asking x plus y less than 1, so you have to draw the again picture, right? So this is the picture, guys. Okay, 0 comma 1 and 0 comma 1. So they are asking this region, area of this. So probability of this region. So probability of this region is nothing but this is A, you can say. So area of A upon the area of C. Area of A कितना हो जाएगा? 1 by 2 into 1 into 1 upon what is area of D? That we have computed, right? So which is nothing but 1 by 4. So answer for this question is 1 by 4. Yes. And you can also, they might give you a question of this kind also, right? You don't have to, they might ask, since you are able to draw the sketch, right? See, support was looking like this. Support was looking like this, okay? This is x and this is y. Sorry. This is y and this is x. They might ask you to write the joint density function also. Okay? So this is a support, right? 2 comma 0. You have to understand this is 2 comma 0 point. This is D. And the area is area of D is 2, right? So what is the density function, guys? Joint density function, that is 1 by the area of D, that is 2, right? And where x and y belongs to D, else 0, right? 0 else, okay? Like everywhere it is gonna be 0. 0 elsewhere. Okay? I believe this is fine, right? So 1 by 4 is the right answer for this question. But suppose they are asking question of the same support. Same support, right? Same support means the support is same, right? This is 0 comma 2 and 2 comma 0. This is the same support they have given, right? Yx. But they are asking you to compute the probability of x plus 2y greater than 1. What is the answer for this question? So x plus 2y is equal to 1 means you have to draw this, right? So what is the line? इसको आप realize करिए पहले. So x is 0. Suppose let's say x is 0. X is 0 means y is gonna be 1 by 2. So this is 1 by 2 point, right? 0 comma 1 by 2. And if y is 0, x is 1. तो ये पॉइंट आप बोल सकते हो, तो ये लाइन आ गई, ये 1 है, 1,0 खत्म. So what is the area, guys? Area of A means this upon area of D. So area of this कितना है? 1/2. Height is 1/2. और ये कितना है? 1/2. 2 into 2. तो इसका आंसर half of gone. 1/8. You see how simply we are able to find the question. Sorry. I made the mistake here. Just wait. This answer will be true for if this is given less than 1, right? This answer is true when it is given as less than 1. But if it is greater than 1, right? Since they have asked in this question, right? Greater than 1. Okay? What they have asked? They have asked greater than 1. Yes. So what is the answer for this question? So greater than 1 means you have to find this area. You have to find the area of this. ये वाला area. So I think I should ये इसको accept कर लेना. Right? So let me find out what they are trying to ask you. They are asking you to find x plus 2y greater than 1. Okay, so let me draw the sketch again. Okay, please correct that. Okay, so region of support is this, x and y. Okay, 0, 2,0, and this is 0,2. Okay, and this line goes to, this is 1/2. So ये आप ऐसा बोल सकते हो कि 1,0, right? So they are not asking this, right? Remember, they are asking you to compute the probability of this region greater than 1. So the area, this is A and total is D, right? So how to find the region? What is the, okay, first of all you have to find this, right? So total is 2, and if you subtract this, right, so total is 2 minus, subtract the this part, that is 1/2 times 1/2 times 1 upon the area is 2, total area of the D. This is the area of, and this is the area of D only, of D. So you can solve this. So 2 minus 1/4/2, which is 7 by 8. So I think इसका answer 7/8 आ रहा है, right? So answer is gonna be 7. It's a very simple process, right? You have to think. Okay, that's it. It's a very simple process. Okay. We will take question in the next class, like category 3. That is going to be the 2D two-dimensional non-uniform case. Right, non-uniform case. Okay. The region of support will be given as uniform only, like unit square only, but the density function will not be uniform, right? Remember, it will be given as non-uniform. So we'll meet in the next session, and thank you. Keep learning. Okay. I hope you might have enjoyed. So you guys can comment also and let me know how the